Okay, Assalamualaikum and salam sejahtera. Okay, so today we will discuss about three-phase system on part 2. Okay, so this part 2 will cover the subtopic as below. Okay, so which is to know the power in three-phase circuits. Okay, about the measurement of the power in a three-phase system in practical. Okay. So what we can say about the power in three-phase for the star and delta connection. Okay, so total power, okay, or active power of P, okay, in a balance of the three-phase, okay, is determined, okay, by taking the power in single phase, okay, and then we multiply, okay, by 3. So in first place, okay, so you just find the phi single phase, okay, the real power of single phase, okay, and you multiply by 3, and then you will get okay, the P total for the three phase circuits. Okay, so for balance system, okay, we know that the phase power quantities, okay, so we are considering, okay, firstly, okay, on to get the power, okay, by using the to get the phase power, okay, by using the B phase and I phase, okay, because we know that the P total is 3, okay, times P phase, P single phase, okay, so which is equivalent, okay, to 3 times V phase times I phase cos theta phase, and the unit is watt. Okay, and then we know that, okay, our three-phase balance system can be either connected in Y connection or delta connection. Okay, we have two types of connection for the three-phase. Okay, so if you refer back, okay, to the Y connection system, okay, we know that your I phase is equivalent to I line. Okay, and your V phase is equal to V line divided by 3. Okay, while okay, for your delta connection, okay, the V phase is equivalent to VL and your I phase is equivalent to IL divided by square root of 3. Okay, so previously, okay, the P total, okay, we are using the phase value, the V phase and I phase. Okay, beside that, okay, we also can, okay, find the phase, the active power, okay, by using the line quantities. Okay, so by using this, okay, respective, okay, I phase and V phase in terms of your IL and VL. So it depends on the data or Y connection. Okay, so for the Y connection, okay, so if you refer back, okay, to your P total here is 3 V phase I phase cos theta phase. Okay, and your V phase here, okay, for your Y connection, okay, is equivalent to VL divided by square root of 3. Okay, and then you substitute your V phase, okay, with your which equivalent to VL divided by square root of 3. Okay, so you can get your P total, your active power, okay, for your three-phase circuits, okay, using the line quantities value is equivalent to square root 3 VLIL cos theta. Okay, so means we can use these two equation for your Y connection. Okay, so which equivalent your P is equivalent to either 3 V phase I phase cos theta or equivalent also to square root of 3 VLIL cos theta. Okay. So for your data connection, okay, as we know that your V phase is equivalent to VL and I phase is equivalent to IL divided by square root of 3. Okay, so we can substitute, okay, your I phase, okay, with your IL equivalent IL divided by square root of 3. Okay, so from here we know that, okay, when you multiply, okay, your 3 IL divided by square root of 3, okay, so we know that, okay, 3, you want to demolish the square root 3, okay, at the bottom of IL, okay, so you just, okay, multiply, okay, the upper and the lower, or the numerator and the upper and the denominator side by square root of 3. Okay, and then from here, okay, so you get only, okay, so you can cancel out your 3, okay, divide by 3 here, and then finally you will get only square root of 3. And then your final equation same as your, okay, Y connection system. Okay, your data connection system, the P total also is a square root 3 VL IL cos theta. So as we can see here, okay, we have two equation or two formula to be used in order to get your real power, which is either you want to use the 3-phase, V-phase, I-phase cos theta, or in terms of line or current, line current or voltage, okay, there you can use, okay, square root 3 VLIL cos theta in order to get your real power. Okay, so related formula, okay, for balanced star and data circuits. Okay, so the active power, as we discussed, okay, is a 3 times P single phase. Okay, it's also equivalent to square root of 3 VLIL cos theta. And also you can find, okay, your P, okay, by using the formula I squared R phase. I phase squared, okay, R phase, okay, or your VR, okay, phase squared divided by R phase. Okay, so your reactive power, okay, is Q phase is equivalent to V phase, I phase, sine phase. Okay, or also I squared X phase, okay, and V squared over X phase. Okay, and your Q total, okay, is a 3 is equivalent to 3 times Q single phase, okay, and also is equivalent to square root 3 VLIL sine theta. Okay, for the appearance power, okay, is V phase I phase, okay, conjugate, okay, I squared Z phase, or equivalent to V phase squared divided by Z phase. Okay, and then your S total, your appearance power, total of appearance power is 3 times S single phase, or also equivalent to, okay, if you want to use VL and IL, is square root 3 VLI IL. Okay, so the power factor, okay, power factor is equivalent to P total divided by S total, or P phase divided by S phase. Okay, and then your power triangle is S is equivalent to P total plus JQ total. Okay, so in practically, okay, in order to measure, okay, your power in three-phase system, we always use two popular methods. Okay, can be one wattmeter method and 2 wattmeter methods. Okay, so for the 1 wattmeter methods, okay, we also can use, okay, 3 wattmeter method if you have, okay, 3 meters. Okay, for the for 1 wattmeter method or 3 wattmeter method here, okay, is used for star connected, okay, balance load with the neutral point accessible. Okay, so you put your wattmeter, okay, okay, in one of the wire, okay, either R, Y or B, okay, and then you go for the neutral, okay, as your negative point. Okay, all right. So for unbalanced, for balanced or unbalanced load, Y or delta, okay, connection, okay, normally we are using 2 wattmeter method. Okay, so this, okay, wattmeter are placed, okay, in between two of the two of the 3-phase wire. Okay, all right. So for 1 wattmeter and 3 wattmeter method, okay, so the calculation. Okay, so this is the configuration, how we configure our 1 wattmeter method. And the second, okay, figure is how the 3 wattmeter method, okay, is implemented. Okay, so a wattmeter, okay, or W is connected, okay, with each current coil in one line. Okay, and the voltage circuit between that line and the neutral point, okay. So the voltage circuit between that line, okay, and the neutral point. So the reading of the wattmeter give the power per phase. Okay. So in order to get the active power, okay, if you are using only 1 wattmeter method, so you just multiply with 3, and then you will get, say, okay, the all 3 wattmeter reading is considered as you get the total active power. Okay. Whereas, okay, for your 3 wattmeter method, okay, you use the 3 wattmeter for each of the 3-phase wire. Okay. And then the reading, okay, you're getting from wattmeter 1 reading, wattmeter 2, and wattmeter 3. The summation of these 3 reading, okay, should be equivalent to, okay, 1 wattmeter reading as what you getting from your wattmeter method times with 3. Okay, so these two methods, okay, can be used, okay, to get the balance load, okay, balance load power reading.